Hello everyone, my name is Ben and I'm an AR developer who makes Snapchat lenses full-time using Lens Studio. In this video, I'm going to be walking you through the turn-based component, which is going to unlock multiplayer gameplay in your lenses. This mechanic will allow you to save data between two players, which enables you to build really fun games. This tutorial will show you how to navigate the API and logic of a turn-based game, so it'll be very scripting focused. So the game we'll be playing today is tic-tac-toe. It's a nice simple game and will give you a great starting point for loading and saving custom data beyond just a simple score value. If you'd like to test out the final project, it'll be linked in the description below so you can reuse the code for your own games. To start, we'll go through the gameplay loop so we can break our game logic up into smaller, easier to understand tasks. Next, we'll create the architecture of the lens, where we set up the visuals that we'll see in our tic-tac-toe game. Then, we'll add the turn-based component and the turn-based player info component and walk through the customization. Then, we will dive into the script where we will build out the logic for each step in our gameplay loop. And finally, we'll do a little polishing and create our endgame screen. So let's begin by walking through the gameplay loop. The beauty of making a turn-based game is that we really only have to build out the logic of one turn, since the loop starts with each player's turn, then ends with them sending the lens to the next player to start their turn. So the first thing that will happen is that the turn starts. This is where we load in the turn-based data and populate our tic-tac-toe grid based on the previous turns. Pretty simple. Next, we're going to create the tap functionality, so the current player can tap one of the grid spaces to play their turn. There's two possible outcomes here. The player could possibly tap a grid space that's already occupied with an X or an O. If that's the case, nothing should happen. If the player taps an unoccupied space, we should populate that space with the appropriate X or O, then save our new game data to include that space. After the player has made their move, we will check if the game is over. If it is, we want to load the game over objects and determine which player won, or if there is a tie. Then, we want to prompt the player to send a snap to a friend to continue the game. If the game is not over, we can skip right to this step. Then, once the player sends the lens to a friend, we loop right back to the start of the lens. When you break your game logic up into bite-sized steps like this, it makes the programming much easier and more manageable. So let's dive into Lens Studio and start building out the lens architecture. For this lens, the only outside assets I'll bring in are three textures: an X, an O, and a line for the grid. We'll start by creating a screen image. This will automatically create an orthographic camera for us, which is perfect because this whole game will be played in screen space. Let's rename the screen region parent object to background, and then rename this image to grid background, along with the material that was created. Then we'll uncheck the base texture and change the base color to black and turn the alpha down to about 0.6 so we'll have a nice slightly see-through square. This will help us define the total size of the tappable space in the tic-tac-toe grid, which will be important later. If you ever have trouble pulling up the 2D scene for whatever reason, try grabbing the 2D scene panel, dragging it off of its pin, and closing it. Then, try double-clicking the image you want to edit, and it should reopen the image in the 2D editor. If the 2D editor doesn't reopen when you double-click the image, it's likely that you accidentally created a regular image, which doesn't include the screen transform component. I only know this because I've accidentally done this myself in almost every project. Next, we'll add another screen image, and this time we'll add the line texture and rename the image and materials line. Now we'll just position this to evenly divide the left side of the total grid space and duplicate it by selecting it in the scene hierarchy, then hitting Command or Control D. Then we can position this line on the right side of the grid, and we'll duplicate it again, rotate it 90 degrees, and reposition it on the top side. Then we'll duplicate it one more time and move it to the bottom. Now that we have our visual grid, we'll need to create an array of invisible, tappable squares, which is what the players will interact with to make their move. For this, I'm going to create a new screen region and rename it to Grid. Then, I'll create a new screen image and make sure it's set under the Grid screen region. I'll rename this image top left and rename the material to invisible. Then in the material, I'll uncheck the base texture and also uncheck the RGB and A values in the color mask. Now let's set the stretch mode of the image to stretch and resize it to match the top left grid space. If you're having trouble doing this, you can hit the magnet button at the top left, and that will help it snap to the right place. In order to make this image tappable, we'll need to add an interaction component, so with the image selected in the scene hierarchy, navigate to the inspector panel and at the bottom click Add Component and search Interaction. Then add the interaction component. We'll set the camera to the orthographic camera and add the image as a mesh visual value. Now we can duplicate this image, rename it to top center, and move it to the top center grid spot. Then duplicate it once more, rename it top right, and move it to the top right spot. Then you can repeat this step for the middle and the bottom rows. Now that we have our whole interaction grid built, let's create 2 more screen regions and rename them X's and O's, which will hold all of the spawned images for the gameplay. Let's create another screen image and call it X, and rename the material, as well as add the X as our base texture. Let's resize it to match the grid spacing, and then we'll right-click and hit Save as Prefab. Let's do the same thing for the O. Create a new image, rename it, and the material, set the new texture, resize it, and then right-click and save as prefab. Let's do this one more time to create an invisible image prefab by duplicating, adding the invisible material, and then saving as a new prefab. This will make our lives easier down the road when we are coding. Now we can disable these prefab objects in the scene hierarchy. This is a good practice because you'll inevitably end up needing to go back into this prefab and modifying something. When you do, you can just click Apply at the top of the inspector and the changes will be saved in your prefab asset. The final screen region we will add will be called the Game Over screen, which is what will populate to show who won or tied. The Game Over screen is essentially a screenshot of the final game state, which will automatically be saved in chat so both people can see the results. For now, we can leave this empty. Okay, so now that we've added the basic visual architecture of the game, let's open up the asset library and search for the turn-based component and install it, along with the turn-based player info component. If you have a previous version of either of these already installed, I'd remove them and install them again, just in case you missed the latest update. Let's put both of these inside a parent scene object called turn-based, then drag it to the top just to organize our scene a little better. Now, let's walk through the turn-based component and how we can modify it in the inspector panel. The first thing I do whenever I add a turn-based component is click on the little eye icon at the top right of the component, which will open up the full documentation directly in Lens Studio. This is really handy because we'll be referencing this a lot when building out our code. Feel free to peruse this at your own pace as there's a lot of information and functionality built into this component. For the most part, we'll end up leaving all the settings in the turn-based component as they are when we load it. This is because most of the logic will be handled in the script we make. The first thing we can modify is the turn limit. If we have a game that will always end after a certain number of turns, we can check this box to ensure the turn-based component ends the game at the right time. There's also the ability to save the turn history for more complex data and logic, as well as the auto restore turn functionality. This helps us build in a kind of anti-cheat measure, so if someone decides they want to reload the lens before finishing their turn for a better outcome, we can save the data between turns and ensure they don't cheat. The tappable areas are a nice feature because they are actually tappable and interactable before the lens even starts. When someone sends you a snap, the tappable areas will be highlighted so you can tap them, which will bring you directly into the game. And you can even pass in data depending on which area was tapped. Just make sure that the total space taken up by all of your tappable areas is not more than 40% of the total screen space. They will not work if they're covering more than that. In the scene section, we can add user 1 and user 2 scene objects that only show up when that user is playing. This is a handy way of enabling certain objects without needing to do any extra code. For this game, we won't need it. There's also a section where we add game over scene objects which only show up when the game is finished. We will end up using this towards the end, so stay tuned. We also have a debug section which allows us to test the gameplay loop directly in Lens Studio. I like to keep this set as is so we can simulate each turn directly in the preview panel by making our move, hitting the camera record button, then clicking X at the top left to start the next turn. Finally, we can have specific behaviors or things happen on specific events, like turn start or game over, but we'll be doing this in the script ourselves. Alrighty, so now it's time to jump into scripting. Let's create a new script called controller and then drag it into the scene hierarchy at the bottom. Double click to open up the text editor and let's get coding. The very first thing we'll need to do is connect the turn-based component to the script. So we will type / at input component.script component and we'll call it turn-based. Then we can hit Control or Command S to save the script, which we know is saved because the little circle next to the script name at the top will disappear and turn into an X. Now we select the controller script in the scene hierarchy and drag the turn-based component into the input that we created. We'll also need to input our invisible and X and O prefab images, so let's add that input, which is asset.objectPrefab. Because this will be an array of 3 images, we'll add square brackets. Then we'll just name it XO. We'll also add a scene object input for the spawn parent, which is the X's and O's screen region, and also the grid parent's screen region, which we'll use later. Let's connect all of these to the script as well. Okay, so we'll need to keep track of several variables here, so let's add them in. We'll need to know the current player index and the other player index, and the current turn. We'll also need to know the positions of each grid space so that we can spawn our X's and O's in the correct spot, so we'll create an array called positions. We'll also need to store an array of our X and O objects that have been spawned, and finally, an array called grid, which is going to be our data that we are saving each turn. Okay, perfect, we are ready to roll. So if we look back at our logic flow diagram, the first thing that happens is that the lens turns on and the turn starts. Let's create a function called turnStarted and connect it to the onTurnStart event in the turn-based component. If we go into the API, we can see that the event is simply called onTurnStart, so we will add this to the function by typing script.turnbased.onTurnStart.add, and then in the parentheses, we will add the function name turnStarted. Inside this function, we'll need to do a few things. First, we need to get the player index and the other player index. So we'll create a new function to do this and call it getPlayers. This function will act a little differently than a regular function. Because the data is being sent and retrieved from Snap's servers, it won't happen right away, but we'll rather send a promise and return the data when it's retrieved later. It usually seems like it happens right away, but on the back end, it needs to wait for the promise to resolve. If you haven't worked with promises in JavaScript, don't worry, I'll make it easy for you. All we need to do to make this work with the promise is to make the function asynchronous by typing async before the function, and then create it as you usually would. Inside the function, we want to set the current player and the other player variables to the correct index, which is either 0 for player 1 or 1 for player 2. Back in the API, there are methods we can use called getCurrentUserIndex and getOtherUserIndex, so let's use them. We'll just type script.turnBased, then add the corresponding method. Now, if we left the code as is, it wouldn't work because we essentially need these values to wait until they are actually retrieved. So we'll just add a wait before we set the values, and then it'll wait until it's retrieved. And now we have our function to get the current and other player index. Let's test this out by printing the current player value after it's set inside the function. I'll just add a print statement and reset the lens. So it prints 0, which means the first player is the current one. Now I'll hit the record button in the preview panel and then the X to start the new player session, and in the logger it now prints 1, which means it's the second player's turn. So it works. Let's move on to getting the current turn, which is essentially the same as getting the player's function. We'll create an async function called getCurrentTurn, and inside it we'll set the current variable using await script.turnBased, and this time we'll use the getTurnCount method. We can also test this out by printing the current turn in the logger and testing in the preview panel. Okay, so the most important thing we need to do when the turn starts is get the grid data, which tells us if there's an X or an O in each spot. This is where some people can get hung up when making turn-based games. Getting the data structure right can be challenging if you aren't familiar with arrays, objects, or classes. You have to be very intentional with how you save and load data to make it as easy as possible for yourself. For more simple games with just a number score for each player, this would be as simple as saving an array of 2 number values. It would be very simple to load and save because we already have the current player index, which means we could simply just set the array at the index of the current player to the new score value every turn. For our use case, we'll need an array of 9 numbers, which will tell us what each grid space should show. Let's make it simple by saying a 0 would represent no X or O, a 1 represents an X, and a 2 represents an O. So to start, the grid array would just contain 9 zeros. We will want to set this as the default value because when we initially load the game for the first time, there will be no saved variable. So let's start by creating a new async function called getGrid. Then we will set the grid array to be our saved variable, which technically doesn't exist yet. So in the API, let's look for getGlobalVariable. And this is the easiest method I've found to load our data. We just need to create a key value, which is a string, so I'll just call it grid data. So we'll type grid equals await script.turnBased.getGlobalVariable, and in the parentheses will be the string grid data. Okay, so we load the values into the grid, but on the very first turn, there are no values, so we need to check for that. We will create an if statement to check if the grid array is undefined or empty, and if it is, we'll set the grid to an array of 9 zeros, showing that it's currently empty visually. After this check is done, we will then populate the grid with X's and O's in their matching positions on the screen. So let's create a function called populateGrid and call it here. So in this function, we need to loop through the entire grid, which is 9 spaces. Let's create a for loop and have it start at I equals 0. Make sure it doesn't go past the length of the grid, so I is less than grid.length, and then increment it by 1, so I++. Then let's create a new variable called newObject, or OBJ, to hold the spawned prefab object. We will then instantiate the prefab, whether it's invisible, X, or O, depending on what the grid value is. 0 is invisible, 1 is X, and 2 is O. So we'll type newObject equals script.xo, and then inside the square bracket we will reference the grid array at an index of I, and then instantiate, and in the parentheses, we will parent the new object to our spawn parent. Next, let's add a reference to the screen image, so variable transform equals newObject.getComponent, and inside we will type in component.screenTransform as a string. We'll then set the position of the screen transform to match the position of the grid space that it's supposed to be in, which will be the positions array at an index of I. Then we'll just need to add that new object into the XO array, so we'll type xoarray.push with the new object variable in the parentheses. Now let's create a function to grab the screen position of each grid space. I'll call the function getPositionGrid. Inside, we'll want to create another for loop, this time looping through the grid parent children. So variable I equals 0, and then I is less than script.gridparent.getChildrenCount, and then I++. Inside the for loop, we'll create a new variable called pose and grab the appropriate child object, get its screen transform, and then get its position from there. So it'll be script.gridparent.getChild at an index of I, and then .getComponent, and then we'll add the screen transform string. And then anchors.getCenter. Then we just need to add this to the positions array, so positions.push with the pause variable inside. Let's call this at the top of the script when it's initialized, right after all of our variable declarations. Then we know the position values are ready to go. Now, the populateGrid function will accurately place the X's and O's in the right spots according to the grid array. Let's test this out by changing some of these zeros into 1s and 2s in our getGrid function. When we save the script with new test values and reset the lens, you can see that they are added perfectly in the preview panel in the correct spots. One thing we need to do before we populate the grid is clear the XO array so we don't have any accidental overlaps. Let's create a new function called clearArray and call it right before the for loop starts. In this function, we will loop through the XO array and destroy every object inside it. Once we're done looping through, we will set the array back to empty and it'll be cleared out. Okay, perfect. So we now have our loading finished. We just need to add our tap functionality so people can actually play. Let's create a new function called gridTapped. We will pass in a parameter called gridIndex, which is going to represent the grid space we are tapping. This function is actually going to be called by another script, so after the function declaration, we'll need to make it accessible to outside scripts. So then we'll type script.gridTapped equals gridtapped. And now let's create a new script and call it gridTap. In this script, we only need to do one thing: find out which grid we are tapping and send it to the gridTapped function. So let's input the controller script at the top and save the script. Then we'll go into our grid parent object in the scene hierarchy and select all of the grid images by selecting the top one, then shift selecting the bottom one. With all the images selected, we'll drag the gridTap script into the inspector and then drag the controller script into the input space that was added. Make sure to double check you've actually added the script to every single image before moving forward. Now, in the script, let's make a tap event function called onTap, and after that function declaration, we'll type script.createEvent, and inside the parentheses, we'll use the tap event string, and then bind it to the onTap function. Because this script is attached to images that contain an interaction component, it'll only fire when these images are tapped. So in the onTap function, we'll fire the gridTapped function by typing script.controller.gridTapped, and inside the parentheses is where we will pass in the index of the image that was tapped. We need to be able to distinguish which grid it was, so let's create a function called getGridIndex and pass that in. Now, in this function, we'll create a variable called parent and set it to the parent of the script object with script.getSceneObject.getParent. Then we'll create a for loop that loops through all of the grid objects. We will then check to see if that child's name is the same as this current object's name, and if it is, then we can return the index of I, which tells us exactly which one we pressed. Okay, so let's test if this is working by going back into the controller script, and inside we'll just print the grid index value. Now, when I tap on the grid spaces, it should print out the correct index of the space I tapped. So top left would be an index of 0, and bottom right would be an index of 8, depending on what order you created your grid. Cool, so now we need to check if there's already an X or an O in the space that we tap. Because if there is, we don't want to add another one on top. This is a simple if statement that checks if the grid array at the index of grid index doesn't equal 0, which means it's not empty, then we will just return and end the function right there, ignoring the tap. Then we can continue with our tap logic. We'll start by setting the grid at grid index to the current player plus 1. We'll do this because we know that the player index will either be 0 or 1, but since X is 1 and O is 2, we want to make sure that those values match. Then we can simply call the populateGrid function, which will clear it out and rebuild it with the new value added. Next, we'll need to make sure that we save that grid value for the next turn. So we'll type script.turnBased.set global variable, and in the parentheses, we'll first reference the key, which is grid data, and then the value that we're setting it to, which is just the grid array. Let's test this out by saving the script, then tapping on the grid and seeing if it correctly populates the X's and O's. Looks good for player 1, so let's send a snap to player 2 and test it out as well. Looks like that works too. Awesome. So our next step is to check if we have any winners. Let's create a new variable called winner, and we'll set it equal to a new function called getWinner. Inside this function, we'll need to check if the grid has 3 in a row in any direction. The easiest way to do this is to just create a lookup table of numbers to show us what combination of 3 grid spaces are winners. Remember back when we checked the index of the grid tapped. That is the same number that we'll be using here to check for the wins. So if we get 3 in the top row, it would be the values 0, 1, and 2. If it's 3 in the middle row, it would be 3, 4, and 5, and the bottom row would be 6, 7, and 8. If we have 3 in a row in the first column, it would be 0, 3, and 6, the second column would be 1, 4, and 7, and the third column would be 2, 5, and 8. We also need to account for diagonals, which would be 0, 4, and 8, and 2, 4, and 6. Okay, so now we essentially have an array of arrays, which tells us all of the possible winning combinations. Now we need to loop through this array and check if they have 3 X's or O's in them. Inside the for loop, we're going to create 3 variables. Let's call them A, B, and C. A is going to represent the wins array at an index of I, and then an index of 0. So we're checking the first number in each of those individual arrays inside the big win array. B is going to be the same, except it's checking the second index, and C is checking the third index. So now that we have all those, we're first going to check if A equals 0. So if it does, that means we automatically don't have a win, since there isn't an X or an O there. We'll type if grid at index of A does not equal 0, then we'll need to check if the other two grid values B and C match A. That means that they're all X's or all O's. So if grid of A equals grid of B, and grid of A equals grid of C, then we have 3 in a row and thus a winner. If all of those conditions are true, then let's return grid at an index of A, which would either be 1 for X or 2 for O. Then, just outside the for loop at the very end of the function, we just want to return 0, which would indicate that there are no winners. Okay, so I know this may have been a little bit confusing, but I promise you we are in the scripting home stretch here. Now we should have a way to check if there's a winner, and if there is, who won. So, back inside our grid tapped function, we need to first check if a winner does not equal 0, which means that there is a valid winner. We'll leave it empty for now, and then we'll add an else statement after that for our tie use case. Inside that else statement, we need to check if the current turn equals 8, which would mean that we have no winner and we are at the last turn, which means it's a tie game. We can leave this empty for now as well. Now we are in the end game, folks. So we are going to create our game over screen objects, and for this we will utilize the turn-based player info components. We are going to create a new image inside the game over screen region, rename the material to player 1, and move it towards the left side of the screen. We'll do this again, but we'll rename the new material player 2 and move it to the right side. Then we'll need to rename the images player 1 winner and player 2 winner respectively. Back up in the turn-based player info component, we are going to make sure that the turn-based component is added at the top, and then we're going to change the user type to user1 so that it's always grabbing the first player info. We'll make sure to enable use Bitmoji sticker and make sure that the output type is set to image, and then we'll set that image to the player 1 winner image. And we'll rename this turn-based info to player 1 winner as well. Then we'll duplicate and we'll rename it to player 2 winner. We'll set the user type to user2, and then we'll set the output image to the player 2 winner image. The sticker type will be sticker ID, and then we're going to go to the bitmoji.com link that shows up below and find a specific image that we want to use for the winner. I'll search win, and I like this one with the big W, so I'm going to right click the image, click copy image address, and then paste it into the sticker ID for each of those components. Now we can duplicate the winner images in components and rename them player 1 loser and player 2 loser. We then just need to set the output image to the correct ones, find a good loser Bitmoji icon, paste in the sticker ID for those, and of course we'll do the same for the tie game. Same process, just duplicate, rename, change image output, and sticker ID. Let's disable all of the images. Okay. Now we need to reference these in the script, so we'll just add 3 new scene object inputs with square brackets because they're going to be arrays, and then we'll name them winners, losers, and tie. Then we'll add the correct images to each of those in the inspector panel. Now, back in the script, inside the grid tapped function, we can enable and disable these objects depending on who the winner is. We know that if there's a winner, it's always going to be the current player, since they are always the last one who has added an X or an O. So we can simply do script.winners and use the current player variable as the index, and then just set enabled to true. And we'll do the same with script.losers, except that index will be the other player. We then need to make sure that the turn-based controller knows that this is the final turn, so it can send the game over screen in chat. Let's look up the API to find what we need, which is the setIsFinalTurn method. And we will type script.turnbased.setIsFinalTurn, and we're going to set that to true. Now, in the tie condition, we can do the same thing essentially, except we're just going to be enabling both of the tie images, and then we're going to set turnBasedIsFinalTurn to true as well. Finally, after all of that game over logic is done, we will end the turn. So we're going to type script.turnbased.endTurn. If you made it this far, congratulations, we have finished scripting. So let's do another test to see if this game over logic works. I'll play through a quick game and see if I get 3 X's in a row, and it should show player 1 on the left as the winner and player 2 as the loser. Cool, alright. So let's do a quick tie test as well. And that works too, amazing. Now let's add a little polish to the game. We can start by adding each player's username above their Bitmoji images. We'll just add a screen text component, position it above the left images, adjust the settings to our liking, and then make sure there's nothing in the text box, and then we'll duplicate it and move it over to the right images. Now we can go into the player 1 turn-based player info component and enable use display name text. Let's set the fallback text to say player 1 and then set the text component. Then we can do the same for player 2 winner info component. To ensure that the text only shows up on game over, let's go into the turn-based component and add those to the game over scene objects list. One final thing that I'd like to adjust is that the images in the foreground don't look very good with the tic-tac-toe stuff behind it. So let's add a Gaussian blur to the scene hierarchy so that we can blur that stuff out. We'll need to make sure that the blur is set to the orthographic layer, which is green, and then set its render order to 1 so it renders over the background images. Then we will select all of the game over screen objects and set their render order to 1 as well, so they show up normally, but everything behind them is blurred. Then we just need to add the Gaussian blur object to the game over scene objects in the turn-based component, and when we test it out, now the game over screen looks much better. And that about wraps up this tutorial. The turn-based component really opens up a whole world of possibilities in your lenses and gives Snapchatters a way to play games with their friends directly inside their chat conversation. While this was a simple use case, there are endless ways that you could utilize the turn-based component to send complex data back and forth. And that would enable all sorts of games like sports, choose your own adventure, or even physics-based games, and so much more. I hope this helped you build out your own turn-based game in Lens Studio. If you have any questions, please feel free to leave a comment below. Thanks for watching, everyone.